inverse tangent function. Okay, tangent function. Can we come up with an inverse? By now we know these functions take in angles and send out ratios. We would like to reverse that. I've got the graph of the tangent function over here. You can see, of course, that just like the others, it fails the horizontal line test. The tangent function does not have an inverse function. So I will need to create the restricted tangent function. I need to find some section of this graph that does pass the horizontal line test. I'd like to pick the biggest piece that I can. And basically what you can see here is as long as I just pick one of these cycles between two of the asymptotes, I will have a section that passes the horizontal line test. The section that was chosen is the section between negative pi over 2 and pi over 2. So very similar to what was chosen for the sine function. I say similar because, of course, technically I can't include the ends. The tangent function is undefined at negative pi over 2 and pi over 2, but any angle in between those two values is part of the restricted tangent function. That function has an inverse, which I can write in the usual way, either as tangent inverse x or as arctan x. And what does this function do? Well, once again, everything is switched. So it takes in a ratio. Now, so far, we've been limited to ratios between negative 1 and 1. Do you see that's not a problem with the tangent function? The tangent function has ratios of 1, 2, 3, 4, going on up forever. There's no limit. Any ratio, any number, can be put into the inverse tangent function. What's going to come out? Well, of course, an angle. Is that also unlimited? Can I get any angle? Absolutely not, because we had to use the restricted tangent function. The only angle you will ever get out of this thing is an angle between negative pi over 2 and positive pi over 2. Notice that there's no equals, so you can't get negative pi over 2 or pi over 2 themselves, just an angle in between those two values. Once again, this is critical information to learn and to know. As far as the angles go, essentially what we've said is inverse sine and inverse tangent, they know about angles between negative 90 and positive 90 degrees. Inverse cosine knows about angles between 0 and 180 degrees. That's the most critical information to remember. Now let's work some quick examples, once again by hand if we can, giving our answers in radians. Arctan of negative root 3, that means the angle whose tangent ratio is negative root 3. When I see a root 3, I'm thinking I'm going to make a reference triangle picture. Root 3 goes with a 30, 60, 90 triangle. What quadrant shall I use? Well, arctan only knows about angles between negative pi over 2 and positive pi over 2. It's a negative ratio, so I must be over here in quadrant 4. I'll draw that reference triangle picture. Let's see, negative root 3 doesn't really look like a ratio, but I can make it look like a ratio by simply putting a 1 underneath it. Tangent is opposite root 3 over adjacent. That would be the 1. The negative obviously goes with the root 3, since that's the y part in the fourth quadrant. Well, this is just our familiar 30, 60, 90 triangle. The 60 goes opposite the root 3. Remember, the inverse tangent function doesn't know about positive angles in the fourth quadrant. That would be way too big of an angle, so I can't use that one. Only knows about angles between negative 90 and positive 90, so I'll have to go this way. The answer to this question is negative 60 degrees, or in radians, negative pi over 3. Okay, how about tangent inverse of 1? Now, so far with numbers like 0 and 1, we've been using quadrantal pictures. That's not the case with tangent. The tangent function doesn't ever return a coordinate. Even on the unit circle, it's a ratio, the ratio of b over a. So I know that that 1 is a ratio, 1 over 1. I'm going to draw a first quadrant picture. I must be in the first quadrant because the ratio is positive. Tangent is opposite over adjacent, and as soon as I do that, I realize, oh, this is just a 45, 45, 90 right triangle. The answer to this question is simply pi over 4. Pi over 4 is the angle whose tangent ratio is 1. The final example, tangent inverse of 5. I know the tempting thing is to write down, oh, this must be undefined. But remember, The tangent function doesn't have a restriction on the ratios. We said you could put anything you want. You can find an angle whose tangent ratio comes out to be 5. You just don't have any nice way of doing that by hand. I can draw the picture. Here it is in the first quadrant, but I don't know what angle that is. I'll have to go to the calculator. It's very simple. Tangent inverse is here in blue. Choose it, type in 5, hit enter, and we've got our answer in radians, 1.3734 radians. That's the angle between negative pi over 2 and pi over 2, whose tangent ratio is 5. Thanks for watching.